So I decided rather than sleeving my FZR125 down to 100cc, that instead I'm going to short stroke it. And to do that means making a new crankshaft. And now that I've got the lathe and the mill set up at home, I was quite keen to give that out as a bit of a challenge. It's a very unusual looking crank due to the fact that it's a 4-cylinder cut down into 2 cylinders. So usually there's the other half of the crankshaft that lives around this area, but instead I'm going to make this part of the crank, which will be shortened from the original stroke as 34.5mm, and I'm reducing it to 27.6. And then this is just an indicative cam chain gear, which I'll just steal off an existing crank and press on. So if I hide some stuff, you can see this here's what I'm going to make. That's the actual crankshaft there that I'm going to make. And then you can see that's the cam gear pressed on. And then this here is the primary drive gear. Just doesn't have its teeth on. I didn't model it for because I don't need it. And then this is the flange, because this is where the thrust, the end thrust of the crank, end float, sorry, if the crank is contained with that gear. So I retain all of that. And then connecting it all together is just that simple shaft. And then this part here comes out all outside the motor, so I can put a pulley on for the supercharger, because I'm going to give it a try twin charging the motor as well. So I have a supercharger to help it when it's off boost, and then once it gets up onto boost, the supercharger will get out of the way and the turbo will take over. So kind of the best of both worlds, just apart from the weight. So yeah, it's pretty simple. Probably the hardest parts, obviously eccentric turning is always a bit of fun, and then actually setting up to cross drill these holes here I think could possibly be a bit of fun as well. But time to get into it really. Yeah, let's go. So we're about to start making the billet short stroke crank for the FZR100. So chunk of 4340. I've already processed a little bit, got my centers in. That's for the 2 webs offsets on both sides. So what I did that was did the center in the lathe, got this parallel, so everything's nice and cylindrically square, and got my centers in front and rear, put it in the mill, clocked it up, drilled for my offset cranks. That's the 2 journals there and there. And then to index it when I flip it over, just milled these flats on it, so then I could put it in the vise, which then orientates it that way, and then do the other centers. So I've got it machined to length. This is my roughing dimensions, so you can see all these diameters are really big, and over length as well. Everything's longer than it needs to be, so I can machine off all of these centers at the end so that they're not left on there. So I'm just about to put it in the lathe and start doing all the concentric turning, as well as I'll make a start while it's spinning concentrically to turn the big end journals as well, because the less material I have to take off it while it's doing the old loopy, the better. So we've got it roughed out. These are all, like I say, all oversized so that I can keep my centers in there. So they'll probably be the last things that get machined down. I've roughed everything in the middle here within 1 mil of finished dimension, and then these here are roughed out as much as I can until I need to put them in the lathe and start spinning them eccentrically. So roughing the crank's going along pretty good. Got one of the journals roughed in there, and then just starting on the other one now. So it's a bit of a head fuck with this thing, spinning like that when you're trying to machine it though. Makes you dizzy. Well, crank's roughed out. Got the journals down to 0.2 of a mil to clean up with the grinder. Once I've got the journals ground, then I can do these journals here. But yeah, it's like that. Alright, well this is some proper home garage shit, but I've put a cylindrical grinding wheel onto a Super Chip Auto bench grinder and dressed it. So I've dressed it square and put the radius in the corner, and then yeah, given a lash. So this is off the grinder, and then just with a little bit of quick polish with some auto sol, and surface finish is remarkable, and I managed to get the dimension with the micrometer as I want. Seems pretty cylindrical as well. I mean, perfectly adequate for this engine. Yeah, works a treat. Here she is, journals all ground. Pretty stoked with that. Well, there she is, all finished up, all pressed together. So now you can see the cam chain gear, the primary drive gear here, and then this little shoulder here, which is for the, so it takes on the end float. Journal bearing there, pulley for the supercharger goes on there, and then you can see the journals and the very lazy way that I did the counterbalancing, just milled some triangles off it. So this is all calculated, measured up the factory balance factor, and I've just retained the same. It seemed to work really well. Yeah, so almost use all of the main bearings again now. So I've got that one. I delete that one, and then use those ones for the crank, obviously. You can see the cross-drilled holes. So that one's what feeds the big end hole there through from there. They were actually a bit tricky to make sure that they lined up when you drilled through, but managed to get that all good. And then you can see the coloration on the steel here. That's from, so to fit these on, rather than press fitting everything and risking having bending and twisting stuff, just because I want a really good interference, because obviously we don't want these to slip. So I just did some calculations, figured out that at this diameter, about 300 degrees temperature differential gave me between 0.03 and 0.04 millimeters. So I aimed for 0.03 millimeters interference, which is a lot if you were to press fit at these small diameters, and then use the color of the steel. So when steel starts to go blue like that, it tells you about 300 degrees. So it's a good indication. And then if you don't hold it there, if you held it there for a long time, you'd affect the heat treatment of the gears. These teeth here have been hardened, induction hardened. So if you held it there for a long period of time, like talking hours, you would slowly start to affect the heat treatment. But for a short blast, just get it on. It seems fine, and I rechecked it, just did the old file test, and she's still hard as nails. So happy with that. Yeah, really just stoked with how it came out. When it heat shrunk itself together, it's very true. I haven't trued it at all yet, but put the dial gauge on it. It's within 0.01 of a millimeter, which is well inside the factory limit. So that's all looking very promising. Yeah. Well, the only liberty that I've really taken at the moment is I haven't nitrided it. So the factory crank is nitrided. The surface it's not hard. It's definitely not like, you know, they say journals should be somewhere around the 55 to 60 Rockwell. It's definitely not that. 55, 60 Rockwell is like what this tooth would be. And the file doesn't even touch it. It's just way too hard. The file easily breaks through the surface of this. So I think this is a little harder than the unhardened 4340, but I'm happy just to try it for now and see how it goes. And if I have excessive wear, then I'll cross that bridge when I get there. If it means I have to make a new crank, so be it. I've got the process figured out now, and it's not like took me about maybe 15-20 hours of work to get to here. And to do the next one now would be probably half that, with having jigs and fixtures and everything all made up and a process figured out to do effectively. Yeah, can't wait to get it in an engine. I've got the new donor motor has been torn apart literally on the bench. So 3LN bottom end. I've already cut the cylinder assembly down. And then what's nice now is I have a mill big enough that I can skim cut that whole face. I've drilled the studs for the upsize studs, and the next main job for me, I have to block that oil squirt a hole there and the oil gallery in this main bearing, and then I need to drill all of these out to M10, which is what my head bolts are, because these little suckers here ain't going to hold on to it. And yeah, make up some new blanking plates. I'm basically going to build a whole second engine to have as a spare, or not a spare, but just as a fresh build. My last one had been through 3 or 4 blow-ups and everything was getting pretty secondhand and tired inside, so This one's thankfully when I pulled this motor down, it looks fantastic inside. All the bearings and everything look great. So yeah, time to get it together. Hopefully I'll get some more work done on it. I've got a surgery on my shoulder on the week's time, not even a week's, 5 days from now. So that's going to put me out of action, I'd say, for a while. But just trying to get through the real big guts of it so I can ponder other things like maybe changing what turbo I'm running and different fuel injection strategies and things. So good times.